Hi, in this video we are going to discuss one of the problem in the linked list, that is the detecting the loop in linked list. So what is mean by the loop? So in generally a linked list will be a linear data structure and the last node will be pointing to null. But here as shown in this linked list, here one first point is connected to second, second is connected to third, third to fourth, fourth node is connected to fifth one, fifth is connected to sixth, then the sixth pointed to third instead of null. Okay, so there exists one loop. So we need to find the loop in a linked list. Okay, so for that we are using the Floyd cycle detection algorithm. What is the Floyd cycle detection algorithm means? There will be two pointers. Initially, that we can call as a slow, which is denoted by S, and fast, that we can uh, represent by letter F. Slow pointer will move one step, means it will be one, first to second, second to third, like that. But the fast pointer will move to two steps, means from first to third, then third to fifth, fifth to again it will be third, like that. So let's do the coding and we can debug also the code. uh, that will be easy for to understand also. So here I have created one class that is not named as linked list loop detection. So this is the class name, and we need to find the loop here. So in order to find the loop, we have to manually create or manually create a loop by pointing the last node to any one of the node in between the nodes. So how we can create that is, manually the loop. So I reused the same data structure. In the previous videos we already created the linked list data structure, so I reused the class here as well, and I have inserted the record. 6 records I have inserted using the one particular insertion class, and this is how I want to create one loop here. So how my loops look like, I just want to add the loop is like this similar way. The loop is I'm going to create, this is the way I'm going to create the loop. I want the loop here. So this is the my linked list, and here I have inserted 6 records. The loop is the last node, right? The last node here, it is a 6, and 6 is pointing to the node 3. So here we can see that there is a loop. The loop is begins from 3, 4, 5, 6. Okay, so if there is a loop, we need to print saying that loop detected. If the loop is not there, then what if the loop is not detected, then we will print the loop is not detected as the message we will print. So how do we create the loop? So I just here I pointed by using the next pointer itself to the third point. Okay, so this is the uh, sixth node, next will be pointing to third node. This is how I created one loop manually. So I have created one method to detect the loop. So this is the loop detection method, and here I passed the linked list as the parameter, and here I'm checking that whether the list is null or list head is equal to null. In both cases we can say that there is no loop. So what it will do, it will return the false. Okay, this is the return type I declared boolean. If the loop dictated, it will true. If the loop didn't find, means it is a false. So in this case, both, I mean, this is a base condition. So if this is true, then there is no loop. Otherwise, we are calling the method detect loop by passing the node. By passing the node, here the node value will be head, will be the node. Okay, so here we are using the one principle, the Floyd's cycle detection principle. That is what we are using here to detect the loop in the a, a linked list as well. So what that rule is, or what the principle is telling, that there will be two pointer. Okay, one will be the slow, I named as slow, another one will be fast. So what we'll do, this will be the slow node will go only by one step, faster node will step by two. That means if we iterate through, for example, if the loop is like this, one say, I mean linked list like 1 2 3 4 5 6. Okay, initially the fast and slow will be pointing to here. Okay, 1. In the next step, slow will be pointing to 2 and fast will be pointing to 3. Okay, then slow will be the next iteration, the slow will be 3, fast will be, we can write like this for better understanding. I'm just writing that one, what I mean by the first iteration, I'm marking the slow pointer as S, so that will be pointing to 1, that will be pointing to 1. I'm just pointing to 1, and fast will be pointing to 1 itself. In second iteration, what will happen? Second iteration, what will be, slow will be pointing to 2, slow will be pointing to 2, slow will be pointing to 2, fast will be pointing to 3. Okay, third iteration, what will happen? Slow will be pointing to 3, fast will be pointing to third next means 5. Okay, so this way we can find out the loop. For example, now we first will reach 5, right? In this example here, whatever be the value, we need to find the third, right? So we can say that again, fourth iteration, what will happen in using this example, fourth iteration, I'm just copying this one. Fourth iteration, what will be the value? Slow will be pointing to 4, correct, and fast will be, what will be fast? Fast now currently where it is? Fast is currently 5th position. Next to next means 5th. Fast in fast, how will it be finding? Next. That means now 5 will be 6. Next 5's next will be 6. Sixth next will be 3. Correct. So it will point to 3 now. Okay. Fifth iteration, what will happen? Fifth iteration, slow will be pointing to 5, fast wherever it will be fast current. Now it is in, see, fast now it is in pointing to 3 here, correct? So fast in this iteration, fifth iteration, what will be next, right? So it fast will become 5. See, fast will become 5. Now we can say that these two are slow, and 5 is also pointing to same node, which means there is a cycle or there is a loop. Okay, so whenever slow and fast pointer pointing to the same node, we can say that there is a loop and we will break that condition. Okay, okay, so this is how we can detect the loop in the linked list. So in code wise, we are calling, we are pointed to variables named as slow and fast, and both now pointing to current node, whatever the node we are passed here, so that is pointing to there. And for iteration we are using the while loop. The condition is here, slow should not be not equal to null, and fast is also not equal to null, and fast next to next should not be a null. Okay, if that case, this will be iterate. Okay, so how it will be, slow is pointing to, in first iteration what will be in this example, first will, in this case, first slow will be slow's next case, correct? It will come to 2, and fast will be, currently it will be, initially it will be first next to next means 3, correct? First will, this is 1, first in initial case, first iteration it will be pointing to 1, correct? And this also 1, currently it will be, here it will be, both will be 1, and here in the first iteration this will become 2, and this will be, first next will be 2, 2's next will be 3, correct? The same way we already find the pictorial, I mean detailed explanation. So whenever the fast and slow pointing to the same, then we will return that value, we will say that is there is a loop is there, loop we find, else it will return false. Okay, so this is how we can find the loop detection. So let's run this example. I saved this one. Loop is detected. Okay, I'm just commenting this line, so there is no loop at all. So what will be the value? Loop is not detected. Okay, and there is one edge case I created. So in this case also, now the list is pointing to null, so in this case there is no loop at all, loop is not detected. I mean, this is 2 time printed because of here it is this code is executed. Okay, so this is how we can find the loop inside the linked list. Thank you.
If you like the video, please click the like button and subscribe for more videos.